let's look at some behavior of power functions. In this example, we are going to look at x squared, x to the fourth, and x to the sixth, and fill out this table and look at the corresponding graph. So I'm going to grab my calculator and plug into x squared first. So I'm going to do -2 squared, and that is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So if I try to plot these points, I'm going to say maybe I have -1 and -2 and 1 and 2. I could label these more detailed, but I'm going to say we have 0, 0. Both -1 and +1 have a y value of 1. And -2 and +2 both have a y value of 4. So just estimating what x squared could look like. It looks like this parabola shape. Here's my x squared function. Now I'm going to do the same thing with x to the fourth. I'm going to grab my calculator and plug in these x values. -2 in parentheses to the fourth gives me a +16. -1 to the fourth is 1. 0 to the fourth is 0. 1 to the fourth is 1, and 2 to the fourth is 16 again. So we're starting at 0, 0. They both go through -1, 1 and +1, 1, but then by -2 we are up at 16. So maybe I'll call right here 16 and 16 for above -2 and 2. So we have another parabola shape, but it's gotten a bit skinnier. We have a steeper increase for x to the fourth. Very similar shape though. Lastly, we're going to explore x to the sixth. So I'm going to do -2 in parentheses to the sixth. It is way up at 64. -1 to the sixth is 1. 0 to the sixth is 0. 1 to the sixth is 1. And 2 to the sixth is 64. So very similar start with some same points for 0 and 1, but then by -2 and 2, we're way up at 64. So we're going to have a pretty steep incline to get way up there. So it's going to be the same looking shape, but even skinnier for this x to the sixth function. So these are x to even powers become more narrow with a higher power. That's the only difference between x squared is the widest, x to the fourth is a bit more narrow, and then x to the sixth is going to be more narrow than that because it's going up really quickly to each side.